The Biuret test is a chemical test used for detecting the presence of peptide bonds. In the presence of peptides, a copper ion forms violet-colored coordination complexes in an alkaline solution. Several variants on the test have been developed, such as the BCA test and the Modified Lowry test. The Biuret reaction can be used to assess the concentration of proteins because peptide bonds occur with the same frequency per amino acid in the peptide. The intensity of the color, and hence the absorption at 540 nm, is directly proportional to the protein concentration, according to the Beer-Lambert law. Despite its name, the reagent does not in fact contain Biuret 2NH. The test is so named because it also gives a positive reaction to the peptide-like bonds in the Biuret molecule. Procedure: an aqueous sample is treated with an equal volume of 1% strong base followed by a few drops of aqueous copper sulfate. If the solution turns purple, protein is present. 5 160 mg per milliliter can be determined. A peptide of a chain length of at least 3 amino acids is necessary for a significant, measurable color shift with these reagents. Biuret reagent: the Biuret reagent is made of sodium hydroxide and hydrated copper sulfate, together with potassium sodium tartrate. Potassium sodium tartrate is added to complex to stabilize the cupric ions. Proteins in the alkaline environment reduce Cu2+ to Cu+, which forms a coordination complex with proteins, leading to a blue to light violet color change. The reagent is commonly used in the Biuret protein assay, a colorimetric test used to determine protein concentration by UV vis spectroscopy at wavelength 565 nm. High-sensitivity variants of the Biuret test: two major modifications of the Biuret test are commonly applied in modern colorimetric analysis of peptides: the bisanonic acid assay and the Lowry assay. In these tests, the Cu+ formed during the Biuret reaction reacts further with other reagents, leading to a deeper color. In the BCA test, Cu+ forms a deep purple complex with bisanonic acid, which allows proteins in the range of 0.0005 to 2 mg per milliliter to be determined. This assay is often referred to as Peirce Assay after the manufacturer of a reagent kit. The complex of Cu+ with BCA absorbs around 562 nm, producing the signature violet color. The BCA protein assay increases the sensitivity of the Biuret test by a factor of around 100, and gives the important benefit of compatibility with samples that contain up to 5% surfactants. The water-soluble BCA copper complex absorbs much more strongly than the peptide copper complex. In the Lowry protein assay, Cu+ is oxidized back to Cu2+ by Movianfolin Kecal-2's reagent, which forms molybdenum blue. Tyrosine residues in the protein also form molybdenum blue under these circumstances. In this way, proteins can be detected in concentrations between 0.005 and 2 mg per milliliter. Molybdenum blue in turn can bind certain organic dyes such as malachite green and or amino, resulting in further amplification of the signal. References. External links and notes: Gold 1990. Organic Compounds in Biological Systems, 2nd ed. John Wiley & Sons, Incorporated. Chemical Reagents.